Alright, another draft physics video presentation. Draft science here on YouTube. Important to point that stuff out, I suppose. Anyway, we'll do comments. It's going to start on gravity anyway. It might stay there. As it relates to the big picture kind of thing, and the fact that by comparison to their theory, like I would suggest you go watch a Sean Carroll video, one of his greatest idea videos or something, and just marvel at how convoluted the universe is. It's this insane, complicated thing apparently, full of all these mysterious events and all this mysterious functioning little bits and 400 forces, 400 anti-fields, all kinds of crap. That you just can't possibly ever draw a picture of it. It would be impossible to do that. It's just too many moving parts. So my alternative theory that works, that does explain magnetism beautifully and electricity, lots of things, the whole theory of light, where the light is actually being produced by an antenna, like all the other radiation, some kind of thing has to, a mechanical device. And that light is also created by little antennas inside, and that the speed of light is what decides the polarization of the light and the wavelength, frankly, and how fast it can move through whatever atoms you're moving it through, and that decides the frequency, because the size of the atoms is going to decide how fast the light gets through the atoms to get to the electrons to create what we call the energy, which is always just a change in a balance. So the simple idea is that all there is this stuff moving the speed of light, little tiny bits of momentum, and a giant universe of it. Now you could just contain it in a giant thing called the universe, if you want to. And the theory could be that no matter what goes into the surface of the universe, it will not come back ordered. It'll come back as re-randomized, in the sense that what hits the outside of the universe, the bubble, won't retain a frequency or anything like that. So there's no images kept. But you don't need to know that part to understand this part. So the universe, we know this force stuff exists, so we know this is, it's a fact. It's pretty elemental, so there's just crap moving in all directions. And when stuff moves in all directions and you put something in there to look at it, it looks like, from the perspective of the thing, that the entire universe is looking at it. Because everything that doesn't hit it just couldn't care less about that. The only thing that's going to matter is the stuff that does hit it, and the stuff that does hit it's going to always look like it's coming right at it. So there's this idea that looks like pressure, doesn't it? I mean, if if stuff is hitting you from the outside constantly, and say reflecting, or reflecting this way, comes in this way, goes out that way. We know it has equilibrium, but we can see it looks like pressure. So that's not very hard to imagine, right? That's easy to follow that dot, those lines. So the only trick is that there's two forms of this force stuff in the universe to complement the fact that there's two kinds of fundamental matter, electrons and protons. Well, you really can't see the difference between green and white, but close enough. Guess I could tilt it a little and then you can see it a little better. But anyway, so electrons and protons. So we just make this the electron, and we'll make, oh shit, that's disappointing. Yeah. I think I have another piece here, but where'd you go, you little piece of shit? There. Yeah. Okay. Slight technical difficulty, but we shall endeavor to persevere in spite of the difficulties. So electrons and protons, and as I explained, the force, it's still force in, force out. The only difference is it's the same force. It reflects nice and right back at you. And if it's a different force, well, then it goes out the side and the motion's the side. or in and out, but it goes into another dimension. And with that simple change in the universe, you can see how the balance of force can become imbalanced. And so a force that's completely even, as soon as you put junk in here, you know, electrons and protons, that force becomes uneven. There can be lots of white going one way, and there can be lots of green going another way, and the environment will change. All right, so with that as background, and the understanding that there is always just reflections, or deflection. But that's all that matter does. Matter moves while it's occupied. So this simple description of how the forces interact with the matter would be, so let's just ignore electrons and protons for the moment, and so let's just say a force comes in and it hits an object. Now all I need to do to create change in the universe, in a sense, is if this force now that was going the speed of light is going something less than, right, the speed of light when it's stuck on this thing. So let's just say it sticks like Velcro, and now this is moving something less than the speed of light. Well, we know that force now has lost some energy because it was going the speed of light, and velocity times mass, okay, and the mass of all these little bits is exactly the same, is momentum, right? P, whatever they use for that, which doesn't make much sense, right? They should do like a triple M. It's momentum. But anyway, that's how I would redo physics. But anyway, yeah, just double the letters. 1.5 letter. Yeah. But anyway, so when this is moving a little slower, we'll do slower by this. Okay, that force now has lost some energy, because it's occupied pushing something that might be a little tiny bit heavier, a little slower. So it just has to be a little bit. So let's understand that gravity is 40, no, yeah, it's like 40 times, no, it's 10, yeah, 10 times the 40th, 10 to the 40th power weaker force. So it's like trillion, it's like double trillion or something. So it's like 2 trillion times weaker as a force than, say, charge, the phenomenon of charge, in terms of the repulsion between electrons and the attraction between electrons and protons is double trillion times more powerful. So this is a tiny change in the speed, but it's a real change, and it's a real loss of real momentum. Until this thing hits something, of course. Then you get it all back. So you didn't really lose it, you just stored it somewhere. So, but anyway, so here let's just follow this through. So this stuck, okay, and it's now moving this thing. Well, now a force coming this way, see, this thing's moving faster, so it's going to end up hitting a force going the opposite way, let's say. And when it does do that, what's going to happen? Well, what's going to happen is this force is going to go this way, because this thing's already got a force on it, all right? And the little bit that's stuck is now going to leave. So technically, okay, this didn't lose any speed. So when the stopping force comes in, there's no loss of its momentum, its ability, its power in the universe isn't changed any, because this arrow just becomes this arrow. So this bit reflecting off, now reflecting, because this moved and this hit, and this one reflecting, okay, because that's right, you stop the object, you don't give the object reverse momentum. So this reflects off, this reflects off, okay, so now you have force back in the universe again, and this thing becomes stationary, it doesn't move now. So now it's going no c, right? Yeah, it's going no velocity. And then you could theorize that another force could come this way. Now it would stick again, okay? Move the object, the whole thing moves, and it waits to hit something that's going to free this back into the universe and restore it to zero again. So you never lose the bit, you never lose anything. Even the momentum is stored in the motion of the object. So when the object's moving, it stored the momentum. See, and when I stopped it, I released the extra bit, the bit that I had, that I was stealing momentum from. So movement is storage of energy. That's sort of an easy statement to make, right? So when an electron or proton are moving, they have stored energy. They've stored a bit hitting them, and they possess it, and until they don't, and that's going to be the rule. And then you could argue that it is possible that they can pile up, but this thing can't go any faster. So like one bit could hit from this direction, and another bit could pile on here, because it's a little slower than the speed of light. But frankly, that probably never happens, and that might be what you call a muon, but it doesn't matter. Don't want to get into things that get more complicated than is necessary. So it's just understanding this idea that things move in a direction, then they have to be stopped by a counter force, and then if you want to move in the opposite direction, you have to hit them with another force. Okay, you have to go through the zero step. There's +1, 0, then +1, or -1 if you want to call it that, minus direction. You have to go through the zero, and to get to the minus. So that's the real path, and that's just an important thing to understand, that motion for these particles is likely motion that's, it moves, it stops, it moves, it stops, it moves, it stops. And, it only transiently holds momentum. It only holds it for a little period of time, and then it has to release it because it's in a very thick environment of interactions, constantly interacting. Unfortunately, that's one of the things, like Feynman argued, the universe could be very simple, but there's just so much of it that you can't follow all along. It's like you could have a gigantic checkerboard, and with just simple checker rules, you could make the image of a Smurf. You could, whatever, pick a pop culture thing, you can make it, you can draw anything on that board, and the thing you draw could be very complicated, and you did it with very simple rules, like an Etch-a-Sketch or something. So so that's what I'm saying the fundamental universe is. And now understanding gravity and charge, and why charge is neutralized as the gravitational force, because the charges all balance out. For as much as much green stuff that's hitting electrons, there's the same amount hitting protons, white stuff hitting protons, and vice versa, and it all works out to be pretty much even, as long as the thing you're interacting with doesn't have much magnetism. That is, not many of its atoms are lined up. Then it's just gravity that's left over. So the idea is, for gravity, is that when two things are interacting in the universe, all I have to do is move. Something just moves inside of this thing, and I know I stored energy. So all I have to do is have atoms going this way, and then atoms going this way. And the fact is that by them moving, there's stored energy. By storing the energy, it means it didn't go where it was going, so it will have less coming out of it than went into it. So it will, in a sense, be constantly producing less energy to the world while stuff is moving inside of it, because movement is the storage of momentum. And so it never has a perfect equilibrium, because with each second it has to do the movement all over again. It can't just take it and then hold it technically forever. It has to keep remaking the movement because of drag. So the idea of drag is just that opposite reaction is going to happen. The more you're moving, the more likely it is you're going to move into the opposite force, and you're going to go back to zero again. You're going to lose your momentum. So as long as the Earth stays hot, active, things moving back and forth, jiggling, then energy won't be getting out, and there'll be a void. And that's what something else falls into, is the fact that it's getting pushed by an even, it's getting pushed by the external universe here. That universe stays at a constant rate over time, and it's getting a little bit less energy out of this material body. Now, a big giant object like the Earth only creates, right? It is kind of a weak force when you think about it. And it's only creating a 10 meter per second kind of velocity in our matter, because it takes a gigantic amount of this movement, these little bits moving back and forth, takes a huge number of them to steal enough energy, to use it up, so as to occupy it, to occupy enough force that it doesn't radiate back out. And so we have a low pressure here, and this falls into the low pressure. So that's the explanation of gravity. You don't fall into the gravity you're explicitly making, you fall into the gravity of this stuff that's moving in here. Movement in here is what you're falling into. You, when you finally get here, are also moving, so out here you're creating more gravity. Okay, so yes, you'll be contributing to the mass and the movement. And the mass just is a recognition that you have to have mass. Okay, to mass just means you have electrons and protons that are moving. Okay, and so as long as they're moving and not stationary, this object has gravity. Because it's giving back to the universe, it always gives back less than it's interacting with. Because at any one moment, it has taken a piece of the universe's momentum to move. It can't move without degrading a photon. It has to slow a photon down to move. And when it stops, it gives it back. So if you can stop all the electrons and protons, no gravity. Keep them moving, gravity. Right, so see if that explains what he's going to gripe about. So, Dino, for me, your theory of gravity is the 800-pound gorilla among the rest of your ideas. I don't even know what that means, but to me, the outstanding part is the magnetism part. There is no rational explanation of the push-pull thing. Nobody has a good theory of magnetism. Mine is the simplest. It makes so much sense. The magnet's a filter. That's why it doesn't get hot. That's why it doesn't have to burn any energy. That's why it doesn't need any uranium. That's why it doesn't need all these things. It's because it's taking energy from the outside and just filtering it, turning it into charge. Okay, among the rest of your ideas, and I only wish you spend more time on it. Well, yeah, to me it's important, but it also gets into the problem of you have to do this thing where you have to imagine gazillions of things, actions happening and all of that. So that's its disadvantages. It's you have to, I can only show you one little element of it. I can't show you it working. It's not as easy to model, just because you need all the little pieces to model it. It may seem simple to you because you already have a full, complete idea in your head. Well, it wasn't ever full and complete. I mean, it was just telling you that, I'm just doing the proof of theory thing here, is that this is where you can understand how you have an engine, okay, that can create difference in the universe. Is that what's the difference? Well, the difference is, to move matter, you have to degrade force. You have to take some of its energy to move it. All right. Let's see. But respectfully, whatever, the explanations are a bit confusing to a lot of us amateurs. Well, you're speaking for all the amateurs. And frankly, I don't see this as being a problem of understanding. I think the problem is they're saying, where's the unicorns? Where's the magic? There's nothing fun in your theory. I think there's too much of that shit going on. They're looking for a religion. I searched for and watched some of your other videos on the subject, but I'm still completely lost. about how the force bits pressure actually work on objects that are inside a massive object. So this is going to go to one of the things that are just so like, duh. I don't know how you could screw this part up. I mean, this is the easy part to understand. Alright, so although conventional physics gets few things right, I think they are correct about some of their idea that an atom, okay, has a lot of empty space in it. Okay, so the proportion of stuff is, tiny, the little tiny protons and neutrons, and then the little tiny electron. And so you have a bunch of empty space in the atoms, and you can understand that a force bit is even smaller, right? So, it's a lot of empty space that's got to fly through. So if you have a zillion of these little force bits, the odds of hitting, isn't too good. Now, from some things we know that it can't be that bad, though, because we know things like mirrors actually work. So it can't be that hard to hit an electron, right? All right, so even if you said, 20 atoms worth of depth that the light goes into a mirror, it goes in 20 atoms at the most. So that would be the theory, right? That this little rain can obviously get through one atom. Yeah, it missed that one, and it goes through another one and goes through here and it misses, and yeah, and then it hits. Okay, so so obviously I'd say the electrons in mass might be a certain size, but in actual size they must be pretty big, because we do hit them with photons, and we wouldn't be if they were as small as their diagram. So I would say they have it backwards in the sense that, yes, the nucleus is small, but the atom is very big, okay, in size, but very small in mass. It's the same mass as these little protons, but it's big, and so that's why it's on the outside and the little things are on the inside. But anyway, even, they're the same except for their charge is different, right? So it just means their color. So we're back to, having to do both colors, and I don't think I need to do that for this explanation. So we're just saying here's a surface with atoms. Okay, here's a bunch of atoms in arrangements, and they're obviously arranged based on the pressure of their electrons to each other, so they have a pressure between them, blah, 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 and a tension between them, and then we're going to shoot this force of gravity that hits everything, and it goes in, and like I said, some pieces will go this deep, some pieces will go that deep, some pieces will bounce right off the first one, so they're going in all kinds of places. Well, let's say they do hit one here. What happens if they hit it again? Right? And then they hit it again. So the idea would be is that, yes, that's stored energy. So that's all storage. So the force gets stored, okay, and it means it can hit more arrows coming this way. So to reflect the last one, like Newton's cradle, the little bits of energy are trapped behind an electron. So you have to hit it, you have to hit it with a force bit to knock this one off. Then you have to hit with another force bit to knock this one off. Then you have to hit with another force bit to knock this one off. And then you have to hit it with another force bit to knock this one off. So you can understand the energy is still there. So when gravity hits this, and then gravity hits this again, and then gravity hits this again, and nothing hits from this side, you can sort of understand that this has three things stored in it, and so it's going to keep pushing down. So it's going to push, this atom pushes on this atom pushes on this atom pushes on this atom. So all of it gets into the object in terms of causing momentum, generally speaking, in the downward direction if it's a solid object, and that's the direction it'll be moved in, and blah 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 blah. So you can sort of get it, right? I mean, I already did the acceleration argument. Obviously gravity, the acceleration doesn't go sideways very much because it doesn't generally rely on atoms pushing into atoms. So the acceleration is more efficient than acceleration of objects where you push just the atoms. When you're pushing just atoms into atoms, and you're not pushing force, I mean the subnuclear pieces of the atom, it's a lot messier. in terms of you create a lot more energy in the wrong direction. All right. I think I'll take care of this next bit. Okay. I searched for and watched some of your other videos on the subject, but I'm still completely lost about how the force bits pressure actually work on objects that are inside of massive objects. Right, so let's say objects inside are electrons and protons. Everything is in the small universe. The whole universe is the small universe. The electrons and protons are making this happen. There's no other thing. They have to move for everything else to move. Nothing happens until they do something. So gravity affects electrons and protons. The force affects electrons and protons. That's all there is. There's force and electrons and protons, and there's nothing else. The universe isn't made out of anything else. And we can call some collections of pattern that are durable, semi-durable. We can call them elements, and then we can call bigger collections compounds, and then we can call them, where do you get bigger in a compound? Organisms. You can do that. But it's just physics at the basis. There's no chemistry. Chemistry just emerges out of physics. Okay. For example, how does the pressure penetrate through layers of earth or concrete? Well, as I pointed out, through pressure, right? Chemical pressure. The atoms push on the other atoms. Atoms don't like atoms, generally speaking. Atoms don't like each other. They have electrons on the outside. They all kind of hate each other, actually. That's actually part of chemistry. Part of chemistry is that, them calculating. Not all their calculations are retarded. But to make compounds, you often have to heat things, right? And what's the heat doing? It's forcing atoms that don't like each other, okay, that got electrons on the outside, don't like each other, and they're forcing them to get close, and that is expel electrons, so now they can pair and share an electron. So that's the whole idea, is to take away this repulsion by giving them enough momentum where the atom doesn't have time to deflect, and it ends up forcing electrons too close to each other, which means one of them has to go and one of them stays. Yeah. And you put more energy in, you can knock 2 electrons out and create even a stronger bond. All right, the earth and concrete yet still exert a force on those materials. I'm just saying, it piles up. The force doesn't go away, so it never dies. So the little bits are hitting it. And you can understand that, yeah, they hit an electron. Well, the electron's in pressure with other electrons, so that means the electrons is ping pong paddles, right? I mean, if I hit this paddle and push it closer to this paddle, well, this paddle's creating a whole bunch of extra pressure now on this paddle, and this paddle either goes this way, or this paddle has to go back this way. So the pressure just builds up. And it's perfectly consistent with what we see. You dig a hole in the earth, and you'll notice there's a lot more pressure down there because there's a bunch of shit on top of you that wants to bury you. Okay. Do at the surface. Earth still weigh the same. Okay. Does a coal miner thousands of feet below the surface of the earth still weigh the same as they do on the surface? Well, not by gravity. That is, if you can create the whole problem with coal mines is what happens. Oh, the ground crushes in sometimes and the whole thing caves in. So your coal mine has to be structured so, the outside pressure is prevented from showing you what gravity's really doing. But yes, technically you're under less gravity because you've changed your gravitational position. Just like if you go up further, okay, you'll have less gravity. You go down deeper, the same thing is happening because you're putting more stuff on one side of you than the other side of you. So now you're making all the material above you will now be gravitationally affecting you in the opposite direction. So, the net balance is, you're less gravitational. um, weighing the same on the surface. If they drop their pickaxe, does it fall at the same rate as at the surface? No, because there's a smaller, you're creating a smaller Earth in a sense, right? I mean, the amount of distance from the other side of the Earth, I guess that's what this is for, drawing. So here, what's causing your gravity on this surface, okay, isn't your distance from the center, it's your distance all the way across. This is the matter that's creating your gravity, all of it. Okay, so you change your position by going a little deeper. You can understand that you've made now this amount is less. Okay, you have less matter below you and you have now matter above you. So now you've lowered the amount of mass creating gravity in this direction. You've increased the amount of mass creating gravity in this direction, so you've obviously compromised your gravity. If you get to the very center of the Earth, then you're back to zero, no gravity. The pitchfork would just stay where you're holding it and you let it go. It would just stay there. All right. Finally, how is it simulation coming along? Well, the simulation isn't doing gravity, it's doing charge. See, that's the complexity here. Gravity requires a different kind of simulation because obviously you're simulating bazillions of particles, so you really have to do something a little different. You know, you have to have algorithms that sort of mimic behavior. You can't really actually do the behaviors. And so the charge simulation is attempting to cheat very little. I'm sure I'm not the only one anxiously waiting. Yes, well, I have learned to be patient. I don't find it very enjoyable either. To see more comprehensive model of your idea in action. You know, the guy's doing it in his spare time, and yeah, he had some time, and now he doesn't have time. But it'll get done. Frankly, you know, people who just like regular physics, I mean, they don't show you, well, they do show you cartoon simulations that are really evil, but they don't bother making real simulations. You know what I mean? They just put powder in a blender and, you know, swirl it around and say that's what black holes look like. It's not very good simulation. So yeah, they're helpful, but you really should be able to imagine it all on your own. You know, it's checkers, for fuck's sake. I mean, it's not that complicated. Alright, so unfortunately, he gets into a whole conversation with the troll, which I think was to his discredit not to notice. And so the troll, apparently that's this other count of Willie Flegland. Anyway, so that's obviously the cowboy. You know, he did some more lying. I mean, so it was back to this argument that Lesage gravity, that somehow I plagiarized it. And frankly, I don't even know how I could be accused of plagiarizing something when I've said the word Lesage gravity hundreds of times. But obviously, if somebody goes back to the origin of this theory, it always started for me from the fact that I'd already said that photons were made out of clumps of particles. Okay, so that's a proven part of the record. I did that in the 6th grade. Okay, in the 6th grade, this is how I described a photon. Clump, 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 little ball of shit, and they're all moving this way. Now I figured out the clumps. Oh, okay, the clumps aren't exactly in alignment because they were created by an antenna of atoms. So now they're moving parallel, but they have polarization. There we go. That's their polarization. So I figured out some new stuff, but I mean, this goes back to when I was in 6th grade. So, and then all I said was, well, what if the photon isn't at a frequency? Then what is it? Right? So what if it's like this? If we don't detect it, you know, our radio receivers don't pick that up. Is it still there? Is it still in the universe? So obviously, I got to ultra mundane particles, right? I found later, somebody told me, So I pointed out that, well, what if gravity is just a bunch of broken photons, right? It's just a bunch of these little bits of energy that come in and create this shadowing effect. They don't get where they're going, and therefore there's less pressure here and more pressure here, and the object moves this way. Not complicated. So that's so 300 years ago, Fadio, a French guy, thought of this idea of particle gravity, and then Lesage took his life's work and resold it, essentially. So, the original guy didn't get much credit, but, it's the way the world works. It's corrupt and evil. But anyway, so that's basically the ultramundane particles was Lesage gravity. Now, it was proposed to Newton. Newton liked it, for years, and then said no. They figured out that, the pieces are going to create too much heat, and the thing will get too hot, or this will happen, or that will happen, because they didn't know what electrons and protons were. They didn't know how efficiently they convert energy without any loss, without any heat. So they couldn't make it make sense. And then there was this problem of drag where, as I pointed out, things like electrons, if they were moving into more of this force, they would be slowed down. They wouldn't be able to get very far without being stopped. And that happens to be the truth. That's exactly true. Electrons don't fire out. We can't make an electron gun that actually can fire an electron very far because it runs into drag and stops. The same with a proton. The only thing that can make it is an object where you take two protons or you take two electrons and you actually allow the force to bounce back and forth this way between them, and these move this way while this ends up moving that way, and that becomes a little bit of an engine. And so this object, a helium nuclei, can survive drag. So once you give it a position, once you crank it up, it keeps going. It just keeps going. It keeps storing energy. Anyway, so so drag is a real thing. So one of the criticisms of Lesage gravity, ironically, can be deduced as being part of the actual universe. It's part of the actual function of electrons and protons. And this is funny that regular physics doesn't even deal with this fact. The fact is you can't make electrons. Electrons are only found in plasmas, in some hot atoms, that are constantly shooting electrons. We can't shoot electrons across space. They won't go there. They won't do that. We can't shoot them to the moon. We can't shoot them anywhere. So drag is already proven, and they're using it as an argument against. Now, obviously, like I said, 300 years ago, they had no idea how the thing damn worked, so they couldn't understand how anything could be frictionless. But obviously it can on the nuclear level. All right, so this accusation that I plagiarized Lesage, there's absolutely no evidence for it. It's a lie. Okay, now people keep lying just for the sake of lying. Again, it's just pure slander, obvious slander. He has no reason to believe, no evidence to believe it. He's just using it to, in some way, insult me and degrade my credibility. It's clearly slander intended to malign and disparage and whatever the legal terms are for slander. And it's all malicious. So you're just proving, again, my legal case for me. Thank you very much for providing even more evidence on top of the evidence you already provided that you don't care about the truth and you don't care about the law. And you don't care about YouTube's rules. Just prove it. Thank you. Just make it so even the most corrupt judge can't admit the truth. That, oh yeah, you're a shithead. All right. So he answers the troll. This is one of those times when getting the technically correct answer does absolutely nothing to lessen the confusion. Well, you're not going to get a technically correct answer because guess what? Regular physics hates particle theory. Okay, so of course they can't even accurately tell you the truth. All right, for me, the last half of this paragraph might as well have been written in Klingon, for for as much sense as it makes to my non-Stanford educated brain. Well, I don't know why you think Stanford is going to educate you. Stanford uses, okay, ironically you say Stanford, right? So when they teach general relativity, guess what they do? They use mock gravity, which is essentially Lesage gravity, because it works so well. So that's the irony. So when Leonard Susskind, you know, the $1 million professor, teaches, you know, Einstein's relativity, what does he end up drawing? Oh, he ends up drawing a convergence of fluid. Okay, that would be just like these little particles, just like them. And the fluid is going into the center of the object. Okay, so you have an endless supply of the fluid, and it goes down a little drain inside the thing, and that goes to infinity. So it's exactly the same thing in the sense that you can understand. It's like exactly the opposite of a light bulb. It's an anti-convergence. You know, an anti-divergence. Okay, so instead of going out, it's going in. Okay, and it's a convergence. That's exactly what these little ultramundane, as I drew originally in the picture, right? The only stuff in the universe that's going to hit you is the stuff that's going to hit you, right? So it's always going to look like it's heading right for you. It's going to be exactly this convergence of energy. So irony there. All right, so now he quotes from Wikipedia. From the premises outlined so far, there arises only a force which is proportional to the surface of the body. So again, this is, Lesage was not about surfaces. So they try to imply that somehow Fadio was suggesting it bounces off surfaces. He never said it bounced off surfaces. So they're not even being honest to the theory. But gravity is proportional to the mass. To satisfy the need for mass proportionality, the theory. See, so now they're telling us why they posited it. And how do you know what his intentions were? See, this is just having these, you know, the Catholics writing history. You know, like Muslim history. Let the Catholics write Muslim history. Yeah, I'm sure it's not going to come out quite right. Anyway. The theory posits that A, the basic elements of matter are very small. Well, that was pretty smart for back 300 years ago, right? So that gross matter consists mostly of empty space, and that the particles are so small that only a small fraction of them would be intercepted by gross matter. So again, just arguing that the little bits, okay, are really small, and you know, they're going to miss most of the time hitting something. The result is that the shadow of each body is proportional to the surface of every single element of matter. So there's no point in saying to the surface of the matter, right? It's just the odds of contact. But yes, there would be the surface area of the actual electrons and protons that the bits eventually have to hit one. Yes, and surface would be proportional to mass. But that, see, again, that object, I would argue, just once you've established that as a fact, how big the electron is, now you've effectively defined how meaningful it is in space. So it really doesn't matter whether you make it small and light or heavy and big. Kind of like the sun. It doesn't matter. You could change the size of the sun as long as you kept the mass the same. It's going to work just as good. If it is then assumed that the elementary opaque elements of the matter are identical, i.e. having the same ratio of density and area, it will follow that the shadow effect at least approximately proportional to the mass. So again, we already know that because that's called mock gravity. So again, they're doing this silly paragraph to describe something they've already conceded works and describes the functions of gravity. It creates the inverse square law, just like the light bulb. Just think of the light bulb the opposite way, that it wasn't hitting you with little bits, that it was consuming okay, bits of energy, and that now the stuff behind you was bright and you were being pushed into the light. Okay, it will follow that the... Okay, we did that. Huh? What? Everything after the words "the result is" seems like completely meaningless jargon. Well, so I guess you didn't read it very well, but it's just saying that the energy is going to be absorbed by moving electrons and protons, by hitting them. Okay, what is an element of matter? That would be an electron or proton. A proton and atom, well, we know, I mean, you should already know that, right? Atoms are emergent things. They're not a something. The something is the electrons and the protons. And the neutrons are just electrons and protons, really close together. So this isn't complicated, right? All right, how is the shadow of a large object proportional to the surface of every single element of matter? It's just the probability of hitting the matter, right? That would be proportional to its size, so to speak. How big is it in the space? And that'll tell you how likely it is that you hit it. And that's essentially defining its mass. Because it really doesn't matter whether I say a force bit hits an electron, okay, and it slows it down, right? The force is now slowed down. Does it matter whether it's 99% slowed down or 98% slowed down or 96% slowed down? So you can make this number anything. All right, and it'll work by just increasing the amount of force or decreasing the amount of matter. So all I do to make the whole thing work is I can adjust any one of those variables. I can make more force, I could make less matter, or I can just change the size. I can change the size of the matter. So it doesn't matter what the truth is. It just matters that you understand the variables, what things are going to affect the outcome. And we know that it turns out that you end up with a number like whatever the gravitational constant is. You end up with a number. All right, an atom. I know Wikipedia sucks, so would anyone else care to take a stab at explaining this idea in a way that even someone with only a BA in political science from whatever Shashank prison here could understand? You know, I think you get it, right? I mean, the shadow idea is pretty simple. I think you can understand. So you're just making an object. You're saying the object has a certain amount of transparency. There's a certain odds, 50-50 you could make it. Who cares? That this little bit will go through the object or this little bit will hit something in the object. So now I've absorbed its energy, right? If it was going this way, I've absorbed its energy because I caused something inside of it to move. All right? So by moving something, I'm absorbing its energy. That energy doesn't get where it was going. It was going over here. I'm not getting it. Therefore, I'm getting this. Seems a lot stronger. So if the wind naturally is blowing 20 miles an hour from both directions, and now I change the wind by putting a sail in the way, and even if it's a sail with a bunch of holes in it, there's still sail in the way, right? So this boat is blocking the wind. It absorbed it in its sail. Okay, the wind didn't get to me, so I'm obviously going to end up start moving this way because his sail absorbed wind. Yeah, you can get that. You could get the idea that actually that would happen. You know, if you put two sailboats and you could create equal wind, you know, all around them, that they would just move right into each other. You could sort of get that, oh yeah, they're both going to block the wind in the other guy's direction, and yeah, the outside pressure is going to smush them right into each other. So I mean, that concept of Lesage gravity is really easy. Alright, so then he, I guess, this is the DraftScience censor. So this is the cowboy under another sock account, which YouTube just seems to let them do anytime they want to. The statement meaning is so obvious you really shouldn't have to ask to have it explained. There are aspects of Wikipedia I don't like, but it doesn't suck. Well, yeah, it does. And there is no reason to say you know it sucks. Well, I know it sucks because I know it has little trolls that run it. Okay, they let people who have real agendas control categories, and that's really dangerous. The hierarchy is just as corrupt as any other hierarchy created out of passion, right? So if you let the passionate people control something, the ones who want to control, don't usually want to control it for any good reasons. Okay, like you. Yeah. Unless you're making a fallacious appeal to ignorance. Now, I was probably making an appeal to, oh yeah, these people probably aren't going to be fair to it anyway, right? Because they don't believe it. And so it's really easy to fuck up something you don't believe in. To cut corners in terms of maligning it. Okay, if you actually have a college degree, which I seriously doubt, doubt based on what? Yeah. Then could you, see again, he just loves making accusations without any evidence. Then you know that the area of the geometric object increases at a slower rate than does its volume with increasing size. But that's the inverse square law. The fact is, a circle volume increases 4 times its circumference because it's expanding in 2 dimensions, a sphere. This is why organic, so it's really important to understand the inverse square law, because because charge, it doesn't exist. I mean, it doesn't exist in the sense of the charges themselves, just because there is no problem with spreading. But the whole cause of this decrease is that when you have a light source, for example, the light is going out in these rays. Now, their physics is really good at drawing these and recognizing that, well, as the ray spreads, right, you decrease the effect of something because the same thing now has to hit a much smaller area. So the force gets weaker proportional to how these lines, how far apart these lines are. But the thing that has to be understood is these lines are moving away from each other in a square fashion. They're not even moving away from each other in this dimension. They're moving away from each other in this dimension. Okay, so they're not only spreading this way, they're spreading this way in and out. And so that means this area gets 4 times bigger. Alright, up here, the sincere doubt it, blah, 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 blah. This is why organic molecules usually don't grow without bonds, increasing size and decreasing the ratio of the surface of the area to the volume, making absorption of nutrients less efficient. Well, regardless of what atoms do, clearly if you're sharing an electron, yes, you've given up something to become bigger. Okay, if the elemental bits of matter are small, here we go. I mean, obviously, electrons and protons are small. The ratio remains large, and so the effect of gravity is more or less proportional to density. Yay! The density of electrons and protons, the things that have mass in the universe, that give the universe all of its mass. The mass of the universe is the electrons and protons. There's nothing else giving the universe any mass. There wouldn't be any mass if there's no electrons and no protons. Okay, which is exactly what is confirmed by observation. You must remember that physicists in the 18th century did not know that atoms existed. Yes, they didn't use the same terminology we use today because the terminology didn't exist at the time. Well, it's not just terminology. It's a conceptual understanding of the fact that all the friction goes away. Friction is a consequence of motion in wrong directions. It isn't an example of energy disappearing or wasted in any real way. So it all goes somewhere. And that's the concept. They just couldn't realize that there could be some kind of interaction in which it was purely kinetic. It seems so obvious that it boggles the mind that you need to ask it. Well, I don't know. It's a pile of crap. Gary is a dangerous idiot. Oh, fuck you. You're a troll, an anonymous, cowardly troll. He has stated publicly that the gas chambers probably didn't ever exist. I never said that. I said 6 million people weren't gassed to death. That's what I said. I never said no one was gassed. I said that was the final solution. It was the end of the war. The Germans were already losing the war. That's when people were gassed. It didn't happen on day one. It didn't happen right away. It's just, sorry, but that's just crap. The policy wasn't kill the Jews. If they wanted to kill the Jews, they would have killed the fucking Jews. They were Nazis, for fuck's sake. You think they'd have some kind of like, oh dear, we're killing Jews. No, they wouldn't care. They would have just done it. So this is all horseshit, but whatever. You know, do your trolley best to lie some more and force me to counter-argue. So you're demonstrating how you're so disruptive. You see, this is the argument I make, that this is real damage you're doing. I'm trying to have a fucking physics conversation, and you're forcing me to address your lies. And see how that works? So let's understand, I've never suggested if there was a Jewish race, there realistically is, that race has anything to do with intelligence or human behavior or ideologies or any of that crap. You can't racially inherit a philosophy of bad behavior. Just not possible. And so if I malign anything, it would be politics. The politics of Israel, for example, I don't think is a good politics. I don't think we should be supporting genetic religious states. I think that's kind of silly, okay, for a modern man to say we have to preserve all the species of man have to have their individual cages, and we have to protect them all from inbreeding and from any kind of pollution. I don't think that's really brilliant. Okay, yeah. So anyway, you are the company you keep. Yeah, exactly. You're a lying piece of scum. You're what the Nazis should have fucking put in camps. Okay. Some more DraftScience censors. I didn't censor. I censor people who are fucking lying, for fuck's sake. You're not allowed to lie. If you can't make a statement without lying, then yes, you're not allowed to comment. And this is just like you're not allowed to stand up in a movie theater and lie about there being a fire. You can stand up and go fire if there's a fucking fire, asshole, and you can't get that simple shit. You're mocking somebody else's intelligence, and you can't even get these simple rules right. Your free speech rights end when you're maliciously lying, shithead. Fucking A. As an aside, it should be noted that the particular passage you quoted demonstrates the faulty logic behind Lesage gravity. Well, it really doesn't. You see, if the elemental particles need to be made small, they don't need to. They really don't, just compared to the force. Obviously, the force is smaller than the objects it's hitting. Wow. And the objects it's hitting aren't like right next to each other in a brick wall. Oh, god damn, these people are so stupid. You see, if the elemental particles need to be made small in order for the theory to work, well, they don't, then there must, it just has to do with the sail. The sail has to, if the sail catches any air, then it's creating a shadow of wind, a wind shadow, and that's just a fact. That's all this theory needs. And then the only other argument is fixing the drag question. But otherwise, the sail analogy works, retard. It doesn't really matter how many holes you put in the sail. All of those things don't matter, but they would matter in the sense that they explain it if you want to be more detailed about how the thing works. I mean, how matter, what we know, all the other facts we know about matter, you have to try to stay consistent with those. And we already knew things about matter, that it can absorb heat, it can reflect heat, it can do a lot of different things. All right, anyway. But if you believe that, then you are, let's see, okay, well, I'll just go back further. Then there must and absolutely must exist some external, okay, so I'll start there. You see, if the external particles need to be made small in order for the theory to work, then there must there absolutely must exist some elemental force holding them together. What? What does that make? Where does that make sense? So ultramundane particles flying through space, radio waves, cosmic background radiation, needs to have some other thing holding them together? No, it doesn't. They're little bits of energy flying in random paths, and that's all you need. So he's too stupid to understand. If I fill a closed box with indestructible BBs, so they just bounce around inside the box, and I put two objects in the box where the BBs reflect off of them, the two objects will move into each other. Just a fact, idiot. Okay. But if you believe that, then you are using circular reasoning. You are explaining an elemental pull force. So there's no elemental pull. So let's understand. Not even part of Lesage's gravity, any pull idea. Clearly the idea was an absence of force on one side, and the push force pushes it into the pull. There's more pressure on one side than the other side. You don't call that, well, this side pulls. No, you call that this side pushes. The side with more pushes things into the side with less. Okay. You are explaining an elemental pull force in terms of simple mechanical robotic push forces. Exactly. But then admit that there exists some other elementary pull force necessary to explain the push force. Why? Where do I need that? I don't need that at all. I just need a box and indestructible BBs. Alright. Which is created in the first place to do away with the pull forces. So that's just a pile of mush. Absolutely no reasoning you can apply. Why does the force need to be pulled anywhere? Yeah, it doesn't. All it needs to have is momentum, and that we can understand. I can say something like perpetual energy bullet, and you could get it. Oh, the bullet just keeps going. It just bounces off things, always going the same speed, and it never loses any speed. It just keeps going through and bouncing around. Ricochet rabbit, You can. It is something you can imagine. It is possible to imagine an object that just moves at a velocity and it just keeps doing that. And all you can do is change its direction. It can go this way, or it could go this way, or it can go back. But it can't do anything else but those choices. It just bounces in different ways off of things. And the only thing I'm changing is I'm saying, well, when it hits an electron, it's still going in the same direction it was going. It's just going a little slower now because it's dragging an electron with it. So that's the only edit or modification. So there is some hope that Farley has been dealt with, but I doubt it. I mean, clearly. He won't be dealt with until I have to go through the process. So soon enough, I'll the process will be, just to see if I can get his address without harassment. I'm going to have to sit there and copyright violation his videos. So if he posts any videos of mine, I'll just copyright violation them. And because I do believe it's malicious use. It's not fair use. So, and malicious use isn't covered under any Fair Use Act anywhere in the universe. You have to have an honest, good purpose, and if you don't, it's not fair use. That's a fact. So, you just can't keep getting away with this crap. I mean, this isn't satire. They're explicit accusations you're making. So you're not making a joke. It couldn't be confused as a joke, So, fuck you. You keep pushing. Go ahead. Just keep pushing. And see what you get, jackass. But anyway. Alright, other comments. This one's fundamentally positive, so we'll ignore that. Hello. In the mechanical universe, again, I already played those fucking videos. So I played the whole fucking series of videos. It's just math crap, most of it. Can you share your opinion on a few questions? One, fuck you. I mean, you don't think I've already done that? I've made over 1,000 videos. You don't think I've already shared my opinion? But anyway, On a fundamental level, what is force? It's little shit moving the speed of light. Little tiny pieces of consistently defined momentum. All the little bits inside of photons, inside of gamma rays, inside of any kind of radiation moving the speed of light. It's all the same. One kind of bullet. 44 caliber, whatever you want to call it. They're all the same bullets. They're all moving the same speed. And all you can do is put them in different arrangements. You can have them at a frequency, and then you can call it light. Okay, if it is charged energy, so what would that even mean? Okay, yes, there's two kinds of bullets. Okay, red ones and blue ones. And there's two kinds of targets, red ones and blue ones. If you hit a red with a red, it reflects. If you hit a red into a blue, it deflects. There, done. And vice versa. That's all you need. 2 plus 2 plus 2 physics. Two kinds of force. Two kinds of matter. Two kinds of interactions. That's all you need. I have to emphasize that more, I guess. Does charged any energy, so whatever that means, imply that photons have mass? Well, of course they have mass because they have momentum. So again, this is just childish nonsense that we are playing some fucking game talking about rest mass versus its actual mass. Like a photon could ever be stopped. There's no such fucking experiment. There's no reason to believe photons ever stop. So it's just a pile of shit. Okay, but obviously they impose momentum. It has to have mass to impose momentum. I mean, mass is a concept, conceptual mass it has to have. Okay, in the classical universe world, oh, fuck you, does all the positive and negative charges require mass? Again, matter has to have mass because it moves. The force has to have mass because it moves. And you can't have momentum without fucking mass. So again, why are we playing this game? Movement without any momentum would be meaningless. That's the invisible man. It just can't do anything. It's an invisible man who is so invisible he can't even pick up a piece of chalk. Such an individual would be called a ghost. And they would be absolutely useless. Meaningless. You could walk right through them. Mag field generated by Earth. The magnetic field generated by the Earth is so minuscule that it has almost nothing to do with anything except creating a little bit of sunscreen. But beyond that, it's meaningless as a mover of the planet Earth. It's so tiny, it can't move the Earth. Okay, mag field generated by a magnet. I don't even know what that means. Positive and negative terminals require mass of the battery. So again, the electrons and protons are mass, shithead. They're the matter. Matter, mass. Kind of similar concepts, but anyway. Of the chemicals causing the reaction. Oh, you're just too fucking on your loop-de-doo. Where did energy and charge originate? Oh, so he wants somebody to tell him who poofed the universe and how did it poof and blah, 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 blah. So it doesn't matter how simple you get, right? You got true elemental forces that are really similar, just red and blue. Okay, bullets. Then you got things that bullets hit, targets, electrons and protons, two different colors. And you got two different ways they interact. Now we have to have a God, right? Who made the universe? No, you don't need somebody to make that. But whatever. Oh, I hate this planet. Captain Hubris was bullied at school. So this is Ken Wheeler stuff. I don't know if he really gets to anything here. Just makes a kind of an ad hominem thing, but it's okay. Ken deserves it. Yes, he just ignores evidence. That's what Ken does. Like I said, he knows that the LEDs are completely controlling what he sees. You know, so he knows the ferrocell isn't bending light. He knows that if you put one LED in and you shoot it in the ferrocell, the one LED shoots the light out and it creates this line. He knows that. Okay, or it might just be. No, I think it's this line actually. It just does this. Creates an arc. So if I create a bunch of these LEDs, then I create a bunch of arcs. and then put another one here, and then I'll create an arc over here, and then I'll create an arc over here. And that's all that's happening here. Is this line is not the LED. The light doesn't bend around here. No, the light refracts into these places and makes it look like it's a bent line, but it's made out of a bunch of straight fucking lines. And Ken knows that. And he just keeps lying. And all the despicable followers are just that, despicable followers. Despicable congregation of dupes and dumbasses. Like any other little cult. A cult of stupid. Stone cold stupid. Ugh. They'll just run over anybody holding a camera. Anybody holding a $2,000 camera. Or just drop a 10-ton weight on them because they're obviously so fucking stupid. Alright. Do you take B vitamin supplement? Rarely, but yes, now and then I do take one because yes, you gotta pay attention to the hype. I ask because you may have symptoms of promiscuous anemia. No, I don't think so, assholes. And this is just such a, the stupid meat eaters, and their stupid little dumb arguments. So again, it's the troll, no doubt, is a meat addict. Just trying to glorify his, silly, petty addiction, his cruelty. And so, obviously, these two are likely connected, little sock accounts. So, again, there's another backstory, another influence of subjects that don't belong here. But at least this is a little bit scientific. But yeah, the reason why our bodies don't make vitamin B is because it's so plentiful in the environment. It's on everything. And clearly just a few thousand years ago, you couldn't avoid getting enough vitamin B because guess what? You were constantly eating some dirt. Okay, and it wasn't until we got to a very sanitized kind of world where we washed the dirt off everything that people became vitamin B short. And that's the truth. So this is just used as an argument that somehow we're not made to be vegetarians. Of course we're made to be vegetarians. That's what we were for millions and millions and millions of years. And it wasn't until the invention of fire that it even became possible not to be vegetarian because our organs can't digest raw meat, and it's just a fact. You'll lose weight if you eat raw meat, okay? You won't thrive. You'll do very poorly because we don't have a gut for it, shit for brains. Clearly we don't have teeth for it. Clearly we don't have catching the animal skills. So on no ground is there anything indicating we are carnivores, that we go out and eat other sentient mammals in any way. Or even, we can't even catch frogs very effectively without technology. I mean, if you're just stuck with your two hands, it's going to be a lot of work just to eat a few frogs. And clearly we can't eat their guts, and we can't eat this. The bacteria kill us. I mean, it just doesn't make any sense to think we go down, chase squirrels, and rip their fur and hide off. I mean, we're not owls. We don't cough up the fur balls. I mean, the whole thing is so fucking stupid. This idiotic notion that we have to justify being cruel to animals, because it's our nature and we can't overcome it. Even if we were Tyrannosauruses and we got intelligence, you don't think Tyrannosauruses could figure out that, ooh, it's quite nasty doing, holding their little cup of tea. It's quite nasty tearing those animals apart before they're dead. I mean, we should at least do something humane to them. And, they could figure this shit out, that it's cruel. Okay, so they're just denying their intelligence, denying their ability to realize it's just an addiction, just a bad habit. And it's a bad habit the human race hasn't had for very long. And completely you can live without it. You don't have to be part of the evildoers. You can choose to not be an evildoer. And it's that simple, but they don't want to because that's inconvenient. It doesn't suit their addiction, and they just don't care. They don't care about the truth, and they don't care about any other feeling thing on this planet but themselves. The end. They suck. Okay, when they die, we should dig them all up and throw them in the garbage. Yeah, it'd be a good thing to do. Let's find all these people's parents, these trolls, and let's throw them in a pile of garbage. That's what they deserve, because they raised assholes. Lying, scummy assholes. Okay, so we'll just dispense with these folks. Oh, YouTube's working really good again. Yeah. How did my connection disconnect? That shouldn't have happened. Fuck you, Verizon. Let's see if it works now. Still didn't work. God, YouTube is just such suck lately. Alright, so somehow my internet is gone. Yeah. What am I paying for, fuckers? I guess I don't need it for this video, but anyway. I guess that's the end of the video. Disconnected. Why am I disconnected? Why? No good reason. Fuck you, Verizon. Alright, anyway. Connection established. See, so what the fuck is your problem? Now it'll disconnect me instantaneously again, but we'll see. Alright, let's try this again. Yay! Yay! Didn't work. Ah, it did now. Okay. Alright. We'll leave that one. Well, we can delete it. Pile of shit. Anyway, oakley doke. So, till the next time, and such and so forth, and whatnot. So, sorry about this, but no commenting on vegetarianism, no commenting on the Holocaust, or whatever, you know, just no. You do it, I'll delete you, I'll block you. Inadvertent subjects, and they just shouldn't have to deal with them on this channel. So your people, if you're offended by something I said, it's your people, okay, who, you know, the ones on your side who can't responsibly have the conversation. They're the hecklers, okay, so your side's looking bad, so clean up your house before you tell me I'm a Holocaust denier or some other horse shit, okay, because I'm not, and, but I'm not going to have the conversation here. And if you're going to try to force it to come on, to be over on here, I mean, you're just showing how, well, maybe you people are out of your minds. Maybe you are a little too stupid, you know. Anyway, till next time, and such.